What's up? Got another video here for you. This is for a business calculus class. If you're not in business calculus, you can still watch it. You'll learn some stuff too. So this is the derivative, and we are going to learn how to find the derivative, but we're going to do it using the definition, using the limit here. So let's go ahead and get started. So the derivative of a function. The derivative of a function f of x with respect to x is the function f prime of x. This right here, this is the notation we can use. This notation we'll use for the derivative. Given by f prime of x is equal to the limit of f of x plus h minus f of x over h as h goes to 0. Now, this right here, this f prime of x, that's some notation for the derivative. Let's see, you can use f prime of x. Another one is dy dx, the derivative of y with respect to x. So it just all depends on, if you have y equals say 2x plus 1, or if you write it f of x equals 2x plus 1, just however you write it. Like if it's y equals, you can write this dy dx, or you could write y prime. The f of x equals, you can write f prime of x, or you could actually write df dx. Okay, that's just different notations to represent the derivative. It doesn't really matter which one you use. All right, so basically what we're doing is we're calculating the difference quotient here, and then we're taking the limit of that as h goes to 0. Okay, now you need to watch the video. I'll say this: you're not ever going to find the derivative like this. Okay, your teacher may put a problem on the test where they specifically tell you to find the derivative using this limit. So you need to know how to do it. I know in my class you will have a problem where you have to use the limit to find the derivative, but then after you work that problem, you'll never do it again. All right, so let's find the derivative. So let's write it down again. The limit as h goes to 0 of f of x plus h minus f of x, all that over h. All right, so we're going to get f prime of x is equal to the limit as h goes to 0. So now we've got f of x plus h. All right, so before we do that, let's just refresh your memory. So forget about this problem right now, okay? And let's look at this. If you have f of x is equal to, say, I don't know, 2x plus 1, and they ask you to find f of 5, then what they're wanting you to do here is take the 5 and plug it in for x. So that would be 2 times 5 plus 1, okay? And if they ask you to find f of negative 3, that would be 2 times negative 3 plus 1. Okay. If they ask you to find f of x plus h, so what they're wanting you to do here is take this x plus h and put it in the place of x. And so that would give us 2 times x plus h plus 1. See, all we did is we replaced this x with x plus h. That's what that's meaning. Okay. All right. So now that we had a little review on that, let's go back to our problem. So we need f of x plus h. So that means we're going to take x plus h and put it in the place of x right here. So that's going to be 16 times x plus h squared. There's your f of x plus h. And then that's what? Minus f of x. Well, what's f of x? F of x is 16x squared. And then all of this is divided by h. And there it is. So you can see here, so look at this. This is your f of x plus h, and this is your f of x. So there you have it. And you know, a lot of times that's the part that students struggle with the most, is plugging that in. Okay? All right. So now what we have to do is we have to simplify this thing. We've got to take this thing right here and simplify it. And the goal is to, you see this h here in the denominator? The goal is to cancel that h out. That's what we're looking to do, is cancel out that h. All right. So here we've got 16. We've got the limit. Don't forget to bring the limit with you. The limit as h goes to 0 of 16 times x squared plus 2xh plus h squared. Okay. All right. So let's look at this real quick. Where did this come from? Okay. Well, this came from x plus h squared, right? I multiplied this out. Remember, x plus h squared is x plus h times x plus h. And then if we FOIL it, x times x is x squared, x times h is xh, h times x is xh, and then h times h is h squared. So we get x squared plus 2xh plus h squared. And basically all I did is I did this part right here. I did that in my head. Okay? If you can do that in your head, that's great. If you can't, go off to the side, write it out like this, and FOIL it out. That's all I did. Okay? All right, so let's get rid of that. And then that's minus. So this part right here is 16, and then I multiplied that out, and then minus 16x squared. And then this is all over h. And so now I get this is equal to the limit as h goes to 0, and all I'm going to do here is distribute the 16. So that's 16x squared plus 32xh plus 16h squared minus 16x squared, all that divided by h. Now look what happens. See, 16x squared minus 16x squared, that goes to 0. And so I'm left with the limit as h goes to 0 of 32xh plus 16h squared over h. And then look at this. I have a common factor of h I can factor out. And so that's equal to the limit as h goes to 0 of h times 32x plus 16h divided by h. So I just factor the h out of the numerator. And then look what happens. The h's cancel, and I'm left with the limit as h goes to 0 of 32x plus 16h. And now I can plug the 0 in for h. So that's 32x plus 16 times 0, which is 32x. And there's your derivative. Okay. Now, later on, well, actually it'll be the video after this one, or the lesson after this one that you learn. You'll be able to do this in one step. Okay. But we've got to learn how to do it like this. All right, so let's see what we have here. Okay, so we've got slope as a derivative, and we've got instantaneous rate of change as a derivative. So the slope of the tangent line to the curve y equals f of x at the point c f of c is, and this is just the notation they're using for the slope of the tangent line, is equal to f prime of c. So that's pretty interesting there. So what they're telling us is that if we take the derivative and we evaluate the derivative at the x value of a point, that gives us the slope of the tangent line at that point. Okay? And I'm going to explain this. You may not be able to picture this, but I'm going to explain it and show you a picture of it in this next example that we do. Okay, I'm going to draw it out. We're going to actually find the slope of the tangent line, and then we're going to find the equation of the tangent line, and then I'm going to draw a picture of it so you can kind of see what we're finding. And then we have instantaneous rate of change as a derivative. The rate of change of f of x with respect to x when x equals c is given by f prime of c. So basically what it is, the derivative is a rate of change. That's what it is, okay? And so if we want to find the rate of change of a function, and I'll explain that in a little, well, I tell you what, let's just kind of go ahead and go over that now, the rate of change. So let's suppose that we have a position function. So if we have a position function, s of t is equal to 16 t squared, okay? This right here, you have a falling object, and when you say you're standing on the top of a tall building and you drop something off the building, well, after 1 second, how high is the object from the ground? Okay, after or how far has it fallen? So what this is giving us, so if I drop something after 1 second, how far has it fallen? After 2 seconds, how far has it fallen? So, well, we can plug that into here, and that'll tell us how far it's fallen. Okay. Now, if we have this function here that represents the position of the object, what would be the change in position? What would that be? What's the change in the position? So if it's fallen, what's the change? It's fallen this way. What's the change in its position? Well, that would be velocity, wouldn't it? So the velocity, that's a rate of change of the position. Okay? So if we wanted to know what's the velocity after 2 seconds, or what's the velocity at 2 seconds? What's the instantaneous velocity at 2 seconds? Well, what we would do is we would find the derivative. So the derivative of s of t, which is the velocity, we'll use v to represent the velocity. Well, the derivative is 32t, right? And how do we know that? Well, you see the 16t squared. We found the derivative up here. So you would need to go through all of this to find this, but we already did it, so we're not going to do it again. So the instantaneous velocity at 2 seconds is 32 times 2, which is 64. Okay, and so let's suppose that time is in seconds, and the and distance is in feet. So the velocity would be what? 64 feet per second. Okay, and so that there's another useful thing there's a useful thing there for the derivative. Okay, if you have a position function and you take the derivative of that position function, then that gives you the velocity, because the velocity, that's the rate of change of the position function. Now let me ask you this. This will come up later, but I'll just mention it now. What would it be if we took the derivative of the velocity function? What's the rate of change in velocity? That would be acceleration. Okay. So, but we'll get into that later on. but I just wanted to mention it. Okay, so there you go. There you have that. All right, so let's look at this. Find the equation of the tangent line to the curve y equals x cubed, where x equal -1. Okay, all right. So the first thing we need to do is we need to find the derivative. So the derivative is equal to the limit as h goes to 0. Now, remember, what's the formula? F of x plus h. So that means the x plus h, we need to put that in the place of x. So that's x plus h cubed minus f of x. I know we have a y written instead of an f of x. It's the same thing. Okay, minus f of x. So that's going to be minus x cubed over h. So basically what we have is we have the limit as h goes to 0 of y of x plus h minus y of x, all that divided by h. I know in the formula it has an f and an f, but our function is y. They represent it with a y instead of a f of x. So it's just y of x plus h, which this is your y of x plus h, and this is your y of x. Okay, this y equals, that's the same thing as if you wrote y of x equals x cubed. Okay, no different. All right, now we have to simplify this thing. So this one, it's a little more involved. Well, simply because of the fact we got to do x plus h cubed. All right, so let's go to the side. Go off to the side. X plus h cubed is equal to x plus h times x plus h times x plus h. So we've got to multiply all that out. So this is going to be x plus h times, so I wrote this x plus h down. Now I've got to full this, so that's x squared, and then x plus h is 2x plus 2x. I'm sorry, xh plus xh is 2xh, and then h times h is h squared. And then I have to multiply this. So I'm going to take the x here and multiply it by each term here. And then I'm going to take the h and multiply it to each term. So that's going to be, what is that? X squared h plus 2xh squared plus h cubed. And can I combine anything? Let's see. 2x squared h plus x squared plus h is 3x squared h, and xh squared plus 2xh squared is 3xh squared plus h cubed. All right, so this is going to be the limit as h goes to 0, and so I cubed that, which is this. So this is going to be replaced with this. So that's x cubed plus 3x squared h plus 3xh squared plus h cubed, and then minus this x cubed here, and that's all over h. So I'm going to erase this now so I'll have the room. All right, so this one, it's a little bit longer problem. So we've got the limit as h goes to 0, and look what happens. You see how the x cubes go to 0. So that's 3x squared h plus 3xh squared plus h cubed over h. And then I can factor out a common factor of h. So that's going to be h times 3x squared plus 3xh plus h squared, all that over h. And so this is going to be the limit as h goes to 0, and you can see here the h's cancel, so that's 3x squared plus 3xh plus h squared. And that's going to be 3x squared plus 3x times 0 plus 0 squared, which is 3x squared. And so what this gives me is y prime is equal to 3x squared. There's my derivative. Okay. All right. Now, what am I doing? I'm trying to find the equation of the tangent line. So, what we're trying to find is what? The equation of a line. We're trying to find the equation of a line. What do I have to find the equation of a line? I've got to have the slope of the line, and I've got to have a point on the line. All right? So, let's worry about the slope in just a second. What about a point on the line? Do I have a point on the line? Well, what would my point be? My point would be, well, they tell me the x-coordinate is -1, right? But I also need what? The y-coordinate. I've got to have the coordinates of that point. Well, if I have the x-coordinate, how do I find the y-coordinate? Well, I take the -1 and plug it in here to find the y, right? So y of -1 is equal to -1 cubed, which is, well, that's -1. Okay? I wish they would have used different numbers. Oh, well, that's fine. All right. So now I have my point on the line, which is -1, -1. Well, now I need what? Now I need the slope. So the slope of my tangent line, let's go back up here. What's the slope of the tangent line? It's just the derivative evaluated at the x-coordinate. So what's the x-coordinates? -1. So that's y prime of -1, which is 3 times -1 squared, which is 3. So now you can see I have a point and I have the slope. So how do I find the equation of a line? Well, remember, y minus y1 equals m times x minus x1. All right? So look at this. Here's, here is m. That's your slope. This is x1. This is y1. So now I have y minus -1. That's this -1. Equals 3 times x minus -1, which is this -1. And so that's going to be y plus 1 equals 3x plus 3. See, the negative and negative make a +1. 3 times 1 is 3. And so now I get y equals 3x plus 2. And there's the equation of your, that's the equation of your tangent line to that curve. All right. So I hope that made sense. So let's kind of take a look at what this looks like. So if you look at the graph, okay, the graph is going to look something like this. That's the graph. This is the graph of y equals x cubed, and -1 is about right here. Okay, there's negative x equal -1, and if you draw this tangent line here, that's your tangent line. Okay, this is the line y equals 3x plus 2. That's what we found, the equation of that tangent line. Okay. All right. Let's move along. All right, so basically what we're doing here is it's some word problems, but what we're doing in the word problems is we're learning different techniques to find derivatives. Okay. So it says a manufacturer determines that when X thousand units of a particular commodity are produced, that the profit generated will be this dollars. At what rate is profit changing? Okay, so they want to know, how is the profit changing? Okay, and they want to know at what rate is it changing when 9,000 units are produced. Okay, so this is a rate of change. It's the change in the profit. So remember, the rate of change of f of x, in this case we have a p of x with respect to x when x is the 9,000 units, is given by the derivative evaluated at the 9,000 units. So we have to find the derivative of p and then evaluate that derivative at 9,000. All right, so let's do that. And so I have p prime of x is equal to the limit as h goes to 0. And this is going to be what? Negative 400 times x plus h squared, okay, plus 6,800 times x plus h minus 12,000 minus, okay, so keep in mind this part right here is your p of x plus h. That's replacing each of the x values with the x plus h. And then that is minus what? That's minus p of x. Well, what's p of x? It's this. So that's negative 400x squared plus 6,800x minus 12,000. I had to squeeze that in there. And that's all divided by h. And so now this is going to be the limit as h goes to 0 of negative 400 times x squared plus 2xh plus h squared. I just fold that out. Remember that's x plus h times x plus h. And that's going to be plus 6,800 x plus 6,800 h minus 12,000. I distributed the 6,800, and then that's going to be plus 400x squared minus 6,800x plus 12,000. And that is all over h. Okay, so that's a lot to squeeze in there. And what I did to go from here to here, I just distributed that negative sign. Okay, and so now I've got to distribute the negative 400, so that's going to be the limit as h goes to 0 of negative 400x squared minus 800xh minus 400h squared plus 6,800x plus 6,800h minus 12,000 plus 400x squared minus 6,800x plus 12,000. And that is all over h. Now let's hope some of this stuff cancels. Well, look, there's a minus 400x squared and a positive 400x squared. There's a 6,800x and a minus 6,800x, and there's a minus 12,000 and a plus 12,000. So all that cancels. So we're left with the limit as h goes to 0 of negative 800xh. Let's see. Okay, so we're good there. So that's minus 400h squared plus 6,800h. All that over h. So after we fold everything out, distributed, canceled out terms, it's not so bad anymore. And so this is going to be the limit as h goes to 0. Now you can see here we can factor out a h. So if we factor out a h, we're left with negative 800x, minus 400h plus 6,800. And that is all over h, and our h's cancel. And so we're left with the limit as h goes to 0 of negative 800x minus 400h plus 6,800. And then we plug the 0 in. That's negative 800x minus 400 times 0 plus 6,800 And that is going to leave us with negative 800x plus 6,800. So we get p prime of x is equal to negative 800x plus 6,800. Okay, that's our derivative. Okay, and so now we take the p prime of x, and we evaluate it at 9,000. Well, it's 9,000, but let's look at that. Am I gonna do p prime of 9,000? Well, let's go back up here and read, because that's what it tells us x is 9,000. So let's see, a manufacturer determines that when x thousand units, there you go, there's the key, when x thousand units. So level of production x, so it says at what rate is profit changing with respect to the level of production x when 9,000 units are sold. So if I make x equal to 9, okay, when x 1,000 units, so whatever x is, that represents thousands. So x equal 9 represents 9,000. So I would just evaluate this at 9. And so that's negative 800 times 9 plus 6,800. And that is going to give me negative $400. So it looks like we would be losing money per 1,000 units. All right. So there you go. So there was your little word problem there, and also you learned to find the derivative of this polynomial here. All right. Significance of the sign of the derivative f prime of x. So if the function f is differentiable at x equals c, then f is increasing at x equals c if f prime of c is positive, and it's decreasing at c if f prime of c is negative. So look at this. So remember, whenever we have a function and we take the derivative and we evaluate it at the x value, what does that do? It gives us the slope of the tangent line. So if you remember from algebra, remember if the line is going like this, it has a positive slope. If the line's going like this, it has a negative slope. Okay? And so can you see here how this tangent line has a positive slope? Well, what's the graph doing? You see how it's increasing? And over here, when we have a negative slope, do you see the graph here? It's decreasing. Okay? We'll talk more about this later on in the course. Okay? About when slopes are positive and negative. We'll get into that more, but I wanted to mention it here. Okay, so originally I have one more problem to work, but I'm gonna work this one, and then I'm gonna write down another problem, and we're gonna just take the derivative of it, because I want you to see how to do that. All right, so example: first compute the derivative of f of x equals square root of x. Then use it to find the equation of the tangent line to the curve y equals square root of x at the point where x equals 4, and then find the rate of change when x equals 1. So basically, we're going to find the equation of a tangent line. Let's do that first. So, well, and before we can do a and b, we need to find, is it y? No, they wrote it as f of x. So we've got f of x is equal to the limit as h goes to 0. Now that's f of x plus h. So we're going to take the x plus h and put it in for x. So that's square root x plus h minus f of x. What's f of x? F of x is square root of x, and that's over h. So let's just write that out here. Remember, limit as h goes to 0 of f of x plus h minus f of x, all that divided by h. So this is your f of x plus h, and this is your f of x. Okay? All right, now how do we simplify this? Well, we did something similar to this back in the first two videos when we were learning how to do limits. So it's going to be the same thing. If you remember in the previous two videos, or the previous lessons that we had, we did what? We rationalized the numerator. Okay, so here I'm going to multiply the numerator and denominator times the conjugate of the denominator. Okay, now remember this up here, this thing that I'm multiplying together. Let me erase all this so I can have room to write. This stuff right here that I'm multiplying together, remember this is like a minus b times a plus b, which is equal to a squared, not plus, a squared minus b squared. And so this, and this should be a prime, f prime of x. So this is the limit as h goes to 0 of a squared, so that's square root of x plus h squared, minus b squared, which is the square root of x squared, all over h times square root of x plus h plus square root of x. Okay, just don't worry about distributing the h to each of those. Just leave it like this. All right, and so now we have the limit as h goes to 0 of x plus h minus x, just squaring each of those square roots, and that's h square root of x plus h plus square root of x. And you can see here how the x's cancel, so that's the limit as h goes to 0 of h over h times square root of x plus h plus square root of x. Okay, and you can see the h's cancel, so that's the limit as h goes to 0 of 1 over square root of x plus h plus square root of x. And now we just plug the 0 in for h, so that's 1 over square root of x plus 0 plus square root of x, which is 1 over square root of x plus square root of x, which is 1 over 2 square roots of x. So I get the derivative f prime of x is equal to 1 over 2 square root of x. All right, so now what are we trying to find? We're trying to find the equation of the tangent line. So we're finding the equation of a line. So what do we need to find the equation of a line? Well, we need the slope and we need a point on the line. So at what point? When x is equal to 4. So it's when, so this is part A. So when x equals 4, and it's for the function y equals square root of x. Okay, so my point is 4. The x coordinate is 4. What's the y coordinate? The y coordinate is the square root of 4, right? I take the 4 and plug it in for x, is 2. So it's at the point 4, 2. Now I need the slope. So the slope of my tangent line is what? Well, that's f prime of 4. I'm evaluating the derivative at the x value. So that's 1 over 2 times 1 over 2 times square root of 4, which is 1 over 2 times 2, which is 1/4. Okay, now let me say this. In some problems they give you, when they ask you to find the equation of a tangent line, so far all they've done is they said find the equation of the tangent line where x equals 4. Sometimes they'll say find the equation of the tangent line at the point 9, 3. They will give you the x and y coordinate, and when they do that, you don't have to do this part. Okay, they already give you the x and the y, which that's nice. That saves you a step. So let's find the equation of the line. Y minus y1 equals m times x minus x1. So we've got y minus 2. See, remember this is your x1, y1, and that's m. So y minus 2 equals 1/4 times x minus 4. And so this is going to be y minus 2 equals 1/4 x minus 1. And so y equals 1/4 x plus 1 when we add the 2 to both sides. All right. So that's not too bad there, is it? And then they want to know the rate of change when x equals 1. So for part B, when x equals 1, they want to know the rate of change. So we just take the derivative and evaluate it at 1. So that's 1 over 2 square root of 1. So I'm plugging the 1 into this thing. And so that's going to be 1 over 2 times 1, which is 1/2. And that's your rate of change. Okay. All right. So that was the last problem that I originally had written down. So what I want to do is I want to work one more problem, and we want to do find the derivative of f of x equals 1 over x. Let's go ahead and do a fraction. Okay, so you can see how to simplify it. So I have f prime of x is equal to the limit as h goes to 0. And remember, it's the limit as h goes to 0 of f of x plus h minus f of x, all that divided by h. So I'm going to replace the x with x plus h. So that's 1 over x plus h minus f of x, which is 1 over x, and that's all divided by h. So you can see that is your f of x plus h, and this is your f of x. Now, how do I simplify this thing? Well, look at it as that h being over 1. Look at it as a complex fraction. And what I want to do is I want to take each term, each one of these terms, this term, and this term, and multiply it by the common denominator. So this is going to be the limit as h goes to 0 of x times x plus h. That's my common denominator. I'm looking at this denominator, this one, and this one. And my common denominator is x times x plus h. And I'm multiplying it times each term. And that's all over h x times x plus h. All right. And then you can see what happens is, see here the x plus h's cancel, and here the x's cancel. And so I'm left with the limit as h goes to 0 of x minus x plus h over xh times x plus h. And so you can see this is the limit as h goes to 0 of x minus h over xh times x plus h. I just distributed the negative. And that's going to give me the limit as h goes to 0 of negative h over xh times x plus h. And you can see here the h's cancel. That's going to leave me with the limit as h goes to 0 of negative 1 over x times x plus h, which now I can just plug the 0 in for h. That's equal to negative 1 over, I just brought the negative out in front of the fraction bar, x times x plus 0, which is negative 1 over x times x, which is negative 1 over x squared. And there's your derivative. So the key to this is to simplifying that is multiplying each term by the common denominator. And look, you may even have something a little more complicated. Let's say they wanted you to find the derivative of this, 1 over x plus 2, if they had that. Well, what would that derivative be? Well, that would be f prime of x is equal to the limit as h goes to 0 of 1 over x plus h plus 2, right? I'm replacing this x with x plus h, okay? Minus 1 over x plus 2, all that divided by h. And you can see it's going to be the same thing. Look at that as being a fraction. And so this would be the limit as h goes to 0. And what am I going to do? I'm going to multiply everything through by the common denominator. 1 over x plus h plus 2 minus x plus 2 times x plus h plus 2 times 1 over x plus 2. And that's all over h times x plus 2 times x plus h plus 2. And look, those cancel, this one cancels, and you can see we're left with the limit as h goes to 0 of x plus 2 minus x plus h plus 2 over h times x plus 2 times x plus h plus 2. See that? So you're getting a little bonus here with these extra problems. I hadn't planned on working them, but I decided to go ahead and do it. Distribute the negative, minus x minus h minus 2 over h times x plus 2 times x plus h plus 2. And so we're left with the limit as h goes to 0. You can see the x's go out and the 2's go out. Yes, I'm going through this one a little quicker because it's similar to the last one. X plus 2 times x plus h plus 2. And you can see the h's cancel, so I'm left with the limit as h goes to 0 of negative 1 over x plus 2 times x plus h plus 2. And so now that's going to give me negative 1 over x plus 2 times x plus 0 plus 2, which is negative 1 over x plus 2 times x plus 2, which is negative 1 over x plus 2 squared. And there would be your derivative. I don't think I made a mistake, but there's your answer right there. All right. So we'll call it a video. You got 2 extra problems in this one. So I hope this one helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.